Scientists have always tried their best to know more and more about this universe, which is just perfect. Hundreds of missions have been launched into space by NASA and other organizations to better comprehend the universe. During these missions, they came up with some of the most strange things, and one such gathered data got them to the results that became the basis of a new discovery: a giant bubble encapsulating us. What exactly is this bubble? How did it form, and why are we trapped inside? These are the questions in everyone's mind, but not after this video. Join us as we take a ride to the biggest bubble ever in this universe. In November 2018, Voyager 2, after its 41 years of epic voyage, finally crossed the boundary that marked the limit of the Sun's influence and entered interstellar space. However, entering interstellar space didn't finish its job. It started sending data from outside the solar system. The data was not what astronomers had expected. Instead, it baffled them. As Voyager 2 moved farther and farther from the Sun, it found out that the density of space was increasing. However, it was not the first time the Voyager felt the density gradient. 6 years before that, Voyager 1 entered interstellar space and felt the same thing that was now being experienced by its fellow craft. This gave scientists the proof that Voyager 1 was right and there is something in the space that is creating a density gradient. To understand it further, first you need to know the space boundaries. The solar system's edge can be defined by a few different boundaries. Of these, what Voyager probes crossed is the heliopause. This boundary is defined by the solar winds that are coming from the Sun, the center of our solar system. The solar winds stream in all directions, and the heliopause is the point at which the outward pressure of the solar wind is no longer powerful enough to push into the wind from interstellar space. The space inside the heliopause is the heliosphere, and thus we can say that it's in the form of a bubble. Now, you might have been thinking that space is a vacuum. Spoiler alert, it's not completely. There, the density of matter is extremely low, but it still exists. The solar wind has an average proton and electron density of 3 to 10 particles per cubic centimeter in the solar system, but it decreases as you get further away from the Sun. The decreased density goes down to around 0.002 electrons per cubic centimeter in the outer heliosphere. As Voyagers moved away, there should be a decrease in density, but what they found was strange. While crossing the heliopause at a distance of 122.6 astronomical units, Voyager 1 detected a plasma density of 0.055 electrons per cubic centimeter, and Voyager 2, at a distance of 119.7 astronomical units, found the plasma density of 0.039 electrons per cubic centimeter. This raised the question of what has caused such an increase in the density. But before we answer the question, there is another thing you need to understand. We have this one heliosphere bubble, and there is an even larger one that encapsulates the smaller one. A quick question. What would you say if someone told you that the space around our solar system is a void and does not contain any intergalactic dust, gas, or clouds? Maybe you call them crazy, but they are right. Recently, astronomers at the Harvard-Smithsonian Center for Astrophysics, or CFA, and the Space Telescope Science Institute published a study in which they explained that all stars and star-forming areas within 500 light-years of Earth are on the surface of a bubble, but not inside, hence providing insights that our solar system is in a void enveloped by a giant, still-expanding cosmic bubble, known as the local bubble that stretches 1,000 light-years across. The notion of bubble is not exactly new. For decades, scientists have speculated its existence, but this time, scientists have observed the net, its shape, and how far it reaches. According to the scientists, the local bubble formed from a series of supernovae. Katherine Zucker, the study's lead author and astronomer at the Center for Astrophysics, explained that over the last 14 million years, explosions near the void's center have shot gas beyond space. The shockwave gathered gas and dust clouds into a thick, freezing, hollow shell that formed the local bubble's surface. By using data visualization software, astronomers created a map of the bubble. They showed that it took at least 15 supernovae to burst and push gas this far. The clouds of gas and dust provided enough fuel for star-forming regions on the bubble's surface. Now, you might be thinking that if the bubble is caused by the explosions of supernovae, then how are we in the middle of it? João Alves, a University of Vienna astrophysicist, explains that when the first supernovae that created the local bubble went off, our sun was far away from the action. But about 5 million years ago, the sun's path through the galaxy took it right into the bubble, and now the sun sits just by luck, almost right in the bubble's center. Research astronomer Zucker said the Earth was over 1,000 light-years away when the local bubble first began to form. They believe the Earth entered the bubble around 5 million years ago, which is in line with other research estimates of radioactive ion isotope deposits from supernovae in the Earth's crust. According to data collected by the European Space Agency's Gaia, when the bubble first formed, it was moving at about 60 miles per second, and now the bubble is still expanding at 4 miles per second. And to our surprise, this is not the only bubble. Just like the stars on the surface of this bubble, there are multiple such clusters found in space. Study author and CFA astronomer Alyssa Goodman explained that more star-forming bubbles are likely to be found throughout the Milky Way. The sun would not be near the middle of a huge bubble if they were not common throughout the galaxy. These bubbles are even interacting with each other, with star-forming regions being at bubble intersections. Because of this, the Milky Way resembles very holy Swiss cheese, where holes in the cheese are blasted out by supernovae, and new stars can form in the cheese around the holes, created by dying stars. In an interview, Zucker even said that the local bubble is just the one that we happen to be inside of at the moment. We think that the sun in its history has likely passed through many, many superbubbles. The team now intends to map out more intergalactic bubbles in order to obtain and complete 3D image of their locations, shapes, and sizes. Astronomers will eventually be able to grasp the role played by dying stars in the birth of new ones by mapping out bubbles and their relationships. Astronomers can also piece together how these bubbles work as nurseries for stars, how the bubbles interact with one another, and how galaxies like the Milky Way evolved through time by mapping out where the bubbles lay in the vast expanse of space. Coming toward the increase in density, one notion is that as the interstellar magnetic field lines pass over the heliopause, they become stronger. They could cause an electromagnetic ion cyclotron instability, causing the plasma in the DRAPE region to be depleted. When Voyager 2 passed through the heliopause, it detected a larger magnetic field than expected. Another idea proposes that material pushed by the interstellar wind slows as it approaches the heliopause, generating a traffic jam. This could have been observed by the New Horizons mission, which detected a faint ultraviolet glow. It was caused by a buildup of neutral hydrogen at the heliopause in 2018. Both theories can be true, but for this, more research is needed. For now, no matter what's with the density, this heliosphere is protecting us. As the solar wind travels across space, it creates a space environment rich in radiation and magnetic fields that recirculate back to the sun. Interstellar cosmic rays and coronal mass ejections, which are concentrated clouds of solar material that burst off the sun, also add to this space environment. This complex environment surrounds the planets and ultimately has a crucial effect on the formation, evolution, and density of the planetary systems. These rays can subtly affect airplanes that fly near the poles, often on trips between Europe or Asia and the US. For one thing, our heliosphere serves as a gigantic shield, shielding the planets from cosmic radiation from the Milky Way. What do you think would have happened to us without this bubble shield? Share your views in the comments section below, and have a great day.